Hello guys and welcome to another episode of How a Computer Works. And in this episode we'll be looking at the famous RAM, or full form is random access memory, and in English term it means accessing something randomly from the memory. And so let's get started about how a RAM works. So there are two pictures around here that I have copied from the book, but how do it know? And so let me get started. As you can see that in this picture I have a below some what not some I have a wire of a bus and wire of setter and enablers, and these two together, setter and enabler, will be used like a register, which will come to a bit later. But for now just understand that this is a bus consists of 8 wires to transfer data, and you should know what a bus is. If you don't, watch the previous video. And the setter and enabler is used for register to capture or memorize or store temporary data. And now comes the more important part, and this is the what we see here is this. Sorry for the okay. Here is sorry. Let me just erase this for the part. Okay. Now here you can see that there are two decoders, 4 into 16 two decoders. You can see around here, and you should watch the previous video where I have explained how a decoder how a decoder works and what it is. So if you didn't see, you can watch the video now. And now you can see that there is a register connected to this two decoder. First let me explain that single register. It has inputs A coming from a bus somewhere else in the PC and somewhere else in the PC, and the SA put part is the setter, goes 1 and 0. The bit pattern: when this SA or setter is 1, then the register can store the bits in A, so that if the setter is off, it won't be able to store. So when the setter is on, it can store the new incoming bits. One of those register, and this is one of those register, maybe I didn't say before, but this is a register which always has setter, or here we call SA on, so that any incoming bits will be remembered instantaneously or all the time, constantly. And now let me explain what the 4 into 16 or the 4 into 16 decoder are, and you can see that there are two of them. First 4 output bit connected, or these 4 input A bit A are connected to this decoder, and other 4, which are these 4 below ones, connected to this decoder. Output are actually laid in a grid pattern, which means that in a grid pattern like this, which means that they will intersect in a 3D dimension like in this picture, but I'll be explaining that a little bit later. Since the two decoder has a horizontal grid such as this one and a vertical grid, they will one vertical grid and only one. Okay, let me again explain this. Suppose this one controls the 16 wires in horizontal grid, so in any time one of these 16 wires one of these 16 wires will be on, and in any time also that's also true for this vertical wire. Anytime one of these 16 wires will only be one on at any single time, and where these are on and this intersect is the bit we are interested at, in which we are actually interested at. So one where both horizontal and vertical will be on, there will be that will have the register on, and we'll be talking about that in a few minutes later. And the rest 255 of them, and as you can see that there are 256 of intersection here. I actually don't have the full picture because that was huge, but we have 256 of them here, and at any single time one of these 250 only one of these 256 will be on and the rest 255 off. And now you can see that there is a bottom S and E, and S for setter and E for enabler. So in part of the circle there are 3 AND gate, and this part will be now, this is actually the focus part of this picture. So now let us talk about this. In part of the circle there are 3 AND gates, this one, and this one, these 3 AND gates, and we have an AND gate level X at the vertical grid and one at horizontal grid. The vertical grids it is here and the horizontals is here. So only at any given time, as I have previously said, only one of these intersection both will be on, and so at any given time X will be on and the rest 255X of them off. So where the X gate is off, the setter and enabler can be turned on that particular place. You can see that through this the AND gates are connected to this setter and enabler of this register, so there we can't use the register if this X gate is off. So we need the X gate which is an AND gate to be on to use this setter and enabler for this X gate. So where the X gate is on at one intersection, its register can be set from bus, and the bus is what we have just talked in these parts. So we can use that register if this X gate is on and can be set, the register can be set from the bus, or its content can, and we can also pass this content to any other place we want. So that is why the X gate needs to be on. So that is just how our RAM works. At any given moment we just suppose this one is the one we want to be interested, we would like to know about, then this decoder will enable this wire and this decoder will enable this wire, and here as it intersect this X gate will be on, and so the register will be on, and according to this bus, if the enabler is on, the bus will be available to all of this wire, and if this register sets the setter on, then the bits which are coming from this byte can be used to retrieve this information or this byte stored in this logic gate, and if needed can pass it to the rest of the bus. So that's just how a memory works. At any single moment, if we want to take any of the specified intersection, we can actually turn that logic gate and on and get that bit to the bus so that they can be used elsewhere. So now that we have learned how our RAM works, we won't be needing that complex images we have just seen, and we will now be simplifying the diagram, and this one is that. So this is the less complex one and this is the even less complex one. First let me just explain what this is. These are the 8 input S we have just seen in the previous pictures, and this is the setter SA, and these are the 8 inputs which are actually coming from the bus. So that we have just seen a bus, and that is the 8 inputs actually, and as we know that bus are 8 wires, there are also 8 inputs here, and these are the setter and enabler we have just seen back then. And you can see that this is RAM 256, which means that we can select 256, one of the 256 bytes at any single time to retrieve what the byte is at the current state. And so this RAM is actually a RAM consists of 256 bits. So this is called RAM 256, and 256 comes from 16 into 16, which are the decoder wires in each of the two decoder we have just seen in the previous video. And now let me explain what this MAR is used by. Full form is called memory sorry for the bad writing, memory address register, which just selects the which one we want to. Sorry for the bit bad handwriting. Called the memory address register, which is just what we have seen, is selects a particular byte by turning on any 8 wires of the two decoders, and where the intersection we get the selected bit to use. So that is what the memory address register is. Just registers one of the 256 of the bits available and to use it somewhere else, and that can be passed along the bus. And now let's come to this more simpler diagram. This is same as this, and as I've drawn two single wires close together, and now this acts as a bus, and we have still 8 wires, but we have just simplified to that of 2, and we again have this SS setter, and also the bus 8 input output, and also this setter and enabler, and again the MAR and RAM 256. So that's how our RAM works. Hope you liked this video. If you liked, please hit the thumbs up button, and subscribe to our channel for few more future videos. So that's all for today. I hope you learned how our RAM works. If you want to learn more about how computer works, you can read this book called But How Do It Know, written by Clark Scott. All of this material I have been using is actually taking help from this wonderful book written by Clark Scott about how actually a computer works, and it is for everyone, so everyone will be able to understand the simple language. And I have been using some of its content. However, some of the content are copyrighted by Clark Scott by himself, but I have been given permission to use it. So anyways, if you want to learn more about how computer works, you can check this simple written book, But How Do It Know.